Hello students, our lesson for today is plane analytic geometry. Analytic geometry deals with the geometric problems using coordinate systems, thereby converting it into algebraic problems. René Descartes, or Cartesius in Latin language, is regarded as the founder of analytic geometry by introducing coordinate systems in 1637. In this figure, we have the Cartesian coordinate system, or also called the rectangular coordinate system. Point O or point 0 is the origin and has coordinates 0, 0. The x-coordinate or abscissa is always measured from the y-axis, that is the distance of a point from the y-axis, or using y-axis as the reference point, while the y-coordinate of the ordinate is always measured from the x-axis, or the distance of the point from the x-axis perpendicularly. The point P has 5 and 3 as abscissa and ordinate respectively. Consider two points whose coordinates are x1, y1 and x2, y2 respectively. A right triangle formed with the distance between 2 points being the hypotenuse is the right triangle. So the distance between 2 points can be calculated using the formula, using the Pythagorean theorem, that is x2 minus x1 squared plus y1 minus y2 minus y1 squared. So in this figure, I have B and A here. This is point A and this is point B. So the distance of B from point A is the difference between their abscissas. This is one side of the right triangle that they form, squared, plus the difference between their ordinates squared. So the slope of the line is, um, consider 2 points whose coordinates are x1, y1 and x2, y2 respectively. A line is formed by connecting the 2 points, just like our earlier example. The slope of a line is defined as the rise per run of the line. So that will be the change in y over change in x. y2 minus y1 over x2 minus x1. Or this is also equal to the tangent of the angle formed between the line and the x-axis. So this is theta. The line parallel to the x-axis has a slope of 0, while a line parallel to the y-axis has a slope of infinity. For parallel lines with slopes of m1 and m2 respectively, the slopes are the same. m1 is equal to m2. For perpendicular lines with a slope of m2 and m1 and m2 respectively, the slope of one is the negative reciprocal of the other. So that is m2 is equal to negative 1 over m1. The angle between two lines, or theta, between lines 1 and 2. So in our figure, we have this one line. The second line is this one. This is the first line, the second line. So we want to know the angle theta between the two. So that is the acute angle between the two. So we can calculate that by using this formula. That is tangent inverse of m2, or the slope of the other, and the second line minus the slope of the first line, all divided by 1 plus m2 m1. Or we could simply just get the angles get the angle between the first line and the x-axis, and the second line and the x-axis, so that will be the angle from the positive x-axis counterclockwise. Then subtract the two and you will get this theta. So the distance between the point and the line, consider a point whose coordinates are x1 and y1 and align with the equation ax plus by plus c is equal to 0. So first you have to convert the equation of the line to this form. ax plus by plus c is equal to 0. The distance can be found using the formula ax1 plus by plus c, by1 plus c all over positive or negative a squared plus b squared. So the coefficient of of x, a, times the coordinate of x of the point, the x coordinate of the point, plus the coefficient of y plus y coordinate of the point, plus the constant c all over the square root of the sum of the squares of the coefficients of a and b, of x and y. So um regarding this sign, positive or negative, we use positive if b is positive, if this one is positive and the point is above the line or to the right of the line. So basically you will just analyze the problem. If the problem asks for the distance of the point from the line, and the point is from the point to the line we go down, so you use the sign of the distance will be negative. But if the question is from the line to the going to the point, and the point is above the distance, the displacement is going up to the right, then that is positive. We use positive distance. So if the point is somewhere here and we are asked to know if the distance from the point to the line, so that is going up, so we use positive distance. But if the question is from the line to the point and we are going down, the distance is negative. Okay, I hope you got that. But from our problem, if we use positive here, is if b is positive and the point is above the line or to the right of the line, b is negative is the point if the point is if positive also if b is negative and the point is below the line or to the left of the line, and negative if otherwise. So the distance between the two lines is, consider two parallel lines with equations as shown in the figure. This is line 1 and this is line 1 and line 2, so we want to know the distance. So the distance here is in absolute value, the absolute value of the difference between the constants all over positive or negative square root of a squared plus b squared. So first you have to convert this equation into a form which is ax plus by plus c, and also this. Then you will get c, the difference between the two constants, all over positive or negative a squared plus b squared, square root of a squared plus b squared. So for the division of line segments, suppose that we have 2 points, so a and b, x1, y1, x2, y2, and we have a line segment formed by these 2 points, and we want to divide it into a certain ratio, and the division is at p, xy. So let r1 and r2, in this case m and n, be corresponding ratio of of its length to the total distance between the 2 points. So what if we want to know the distance on the point P, the coordinates of the point P, which is 2/3 of the way from A to B. This is 1/3. If this is 2/3, this is 1/3. Okay? So x is equal to x2 r1. So we want to know this coordinate x2 r1, this one, plus x1 r1 r2 all over r1 plus r2. R1 plus r2 is 2/3 plus 1/3 is equal to 1. So we already know x. And how about y? So y, same procedure. You will just change x2 to y2 and x1 to y1. You can also find that area of any polygon given its coordinates, the coordinates of its vertices using analytic geometry. But in this equation, in this example, we are just going to um use use a triangle because it's the simplest polygon out there. So consider a polygon with the vertices given as x3, x1, y1, x2, y2, and x3, y3. And the vertices, the area of this polygon is equal to the 1/2 of the determinant of the matrix formed by its coordinates. And the vertices must be written in counterclockwise direction. So in this example, we start from A, we go counterclockwise. So our equation here is wrong. It should be x1, y1, x3, y3, and x2, y2. Okay. So if you have a calculator, this is easy to know that it to solve. So the determinant x1, y1, x2, 3y3, x2, y2. But if you don't, just multiply this, then rewrite the first column, then multiply this. Get the products multiplying downward diagonally, then multiply upward diagonally, do the same. So get the sum of the products here, get the sum of the products here, then get the sum of the products here, get the sum of the products here, then this is negative, then the sum of all the products here is negative, then add the 2, then multiply it by 1/2. A line is defined by the shortest distance between 2 points. The following are the equations of the lines. So the general equation is ax plus by plus c is equal to 0. So in analytic geometry, when you say general equation, it is usually this form. So all the other terms is equal to 0. So for example, in quadratic equation, the general form is ax squared plus bx plus c is equal to 0. For the point slope form, if you're given a point and the slope, you can just write it as y minus y sub 1 is equal to mx minus x sub 1. For the slope intercept form, this is another common way of writing lines, equation of lines. We have y is equal to mx plus b. And finally, for the 2-point form, if you're given 2 points and you want to know what the equation is, so you can just write it as y minus y sub 1 is equal to y2 minus y1 over x2 minus x1 times x minus x1. So basically, this is just the point slope form. Let's have a sample problem. So find the distance between 2 points A, 4, negative 3, and B, negative 2 and 5. So first, you will have to plot the points so that um, you can just imagine how far these two lines are together. But you can just keep that step altogether and use the distance formula. So the distance formula is d is equal to x2 minus x1 squared plus y2 minus y1 squared. So x2 is, don't worry if you interchange the 2 because you will just square it. So the absolute um value will remain. So for the abscissas, negative 2 minus 4 squared plus 5 minus negative 3 squared. So that will become 6 squared plus 8 squared. That will be the square root of 100 and distance is equal to 10. Another problem, find the coordinates of the points which is 3/5 of the way from point 2, negative 5 and point 3, negative 5. So first, in this problem, you will really have to plot the 2 points so that you will know which one is the point that is 3/5 of the way. So direction is important here. So it says that from the point 2, negative 5, if we want to plot that point, so you can plot graphs in using the Desmos app. Just download it and you can graph anything. So the point is 2, negative 5, so that's point A. Then the second point is 3, negative 5, 3, positive 5, negative 3, positive 5. So this is that point. So we want to know from this point to that point, 3/5 of the coordinate of the point, 3/5 from of the way. So I divided the line into 5 line segments. Then from point A, the 3/5 of the way is 1, 2, and 3. So that is this point. So we know that our point should be in the second quadrant. So using our formula, x is equal to x2 r1 plus x1 r2. x2 is the coordinate of b, x coordinate of b, -3 plus positive 2, -3 times 3/5, that is our r1, plus 2 times 2/5, all over 3/5 plus 2/5 is equal to -1. So that is here. We already know that our um, x coordinate is correct. So about y, same procedure, just change x to y. So 5 times 3/5 times -5 times 2/5 all over 3/5 plus 2/5 is equal to 1. So our answer is -1, 1, and that corresponds to this point. So we know that we are correct. So sample problem number 3, find the angle between the two lines. I already graphed the two lines, 3x plus 2y plus 6 and x plus y is 3x plus 2y is equal to 6 and x plus y is equal to 6. So the angle should be this angle, this acute angle, not this one, not this one, this one. Okay. So for the solution, first we want to know the slopes of the two lines first, then apply this formula. So to get the slope of this, I change this equation into the point slope form, that is mx is equal to mx plus b is equal to y. So transpose this to the other side of the equation, and this also, then you will get -2y is equal to 3x plus y, 3x plus 6. So so that the um the y will remain here. Divide the whole equation by 2. So our the slope of our first line is -3 over 2. Then from x plus y is equal to 6, um, move it to the other side of the equation. We have y is equal to 6 plus x, 6 minus x. So our slope is -1. So using the equation that we have tangent inverse of -3 over 2 plus 1 over 1 minus 3 over 2 times 1. And we get an answer of 45. Next problem, find the distance of the line 3x plus 4y is equal to 5 from the origin. So from the origin, we want to know the distance of this line. So our distance should be positive because from the origin, we are going to move upwards to the right. Okay. So using the formula, d is equal to ax1 plus by1 plus c all over positive or negative a squared plus b squared. 3 times 0 plus 4 times 0 plus 5 all over the square root of 3 squared plus 4 squared. And we know that the distance should be positive. So our answer is 1. So final problem for this lesson. Find the distance between the given lines 4x minus 3y is equal to 12 and 4x minus 3y is equal to -8. So first we want to change the equation of the lines into general form. So we have um, transpose this into this side of the equation. So we have 4x minus 3y is equal to 4x minus 3y minus 12 is equal to 0, and 4x minus 3y plus 8 is equal to 0. So using the equations, t is equal to c1 minus c2 all over positive or negative a squared plus b squared. So I think our constants are wrong. So the first constant is negative 12. So negative times negative is equal to positive. Then our second constant is positive 8. So should have 8 plus 12 all over the square root of 4 squared plus negative 3 squared. So this is 25 and this is 20. 20 over 25, 20 over square root of 25, 20 over 5 is equal to 4. So we are saved by the absolute value sign, but the constant should be positive. So that will be all for today. Thank you for um, staying with me through this lesson, and see you next time.